Every time you step onto a plane, you're placing your trust in this massive, invisible network that works around the clock to keep you safe. But have you ever really stopped to think about what goes on behind the scenes, after the cabin doors close and the planes are all parked for the night? Okay, let's get into it.
The sheer scale of modern aviation is just mind-boggling, right? So how does this whole global system work so reliably, day in and day out? Well, it's definitely not magic, and it's not just luck. The real answer lies in this incredibly organized, high-stakes industry that most people never, ever see.
Yep, you heard that right. A global pit crew. Imagine a network of highly skilled engineers, technicians, and logistics experts all dedicated to one single mission, making sure every single aircraft is in absolutely perfect working condition. And this industry, it has a very specific and very important name.
So, this global pit crew we're talking about, the industry is called MRO. It's an acronym that honestly holds the entire aviation world together. And in this first part, we're going to break down exactly what it is and why it is so incredibly vital.
MRO stands for Maintenance, Repair, and Overhaul. Now, it's a concept you'll find in a lot of fields, but in aviation, it is absolutely critical. We're talking about the entire process of restoring any part of an aircraft, from a tiny little screw to a massive jet engine, back to its peak required function.
So why is MRO just completely non-negotiable? Well, it really boils down to three big things. First, efficiency. A plane sitting on the ground is a plane that's losing money. MRO keeps them in the air, earning revenue. Second, and this is the big one, is safety. The standards are unbelievably high for very, very good reason. And finally, cost. A small routine fix today, like replacing a worn seal that costs maybe a few bucks, prevents a catastrophic and wildly expensive engine failure down the road that could cost millions.
Okay, so MRO isn't just one single giant company. It's actually a really complex ecosystem of all different kinds of players, and each one has a very specific role. So let's take a look at who actually makes up this whole ecosystem.
You've basically got four main types of MRO providers. First up, you have in-house MROs. That's pretty straightforward. They're part of the airline itself. Then you have the independent third parties. These guys are totally unaffiliated and can work for any airline. Next, there are the airline third parties, like Garuda's GMF. They're owned by a big airline, but they also take on outside clients. And finally, you have OEM MROs. These are run by the original equipment manufacturers, think Boeing or Airbus. You're getting maintenance straight from the people who actually designed and built the plane.
But look, keeping these planes airworthy is about way more than just skilled mechanics. It's a logistical nightmare. It's a massive global puzzle of getting the exact right part to the right plane at precisely the right time anywhere on the planet. So how do they solve this thing?
The answer is something called supply chain management, or SCM. As Douglas M. Lambert puts it here, it's all about integrating everything, from the original supplier of a part all the way to the end user, which is the airline. It's not just about managing the parts themselves, but all the services and the flow of information that goes along with them.
A simpler way to think about it, SEM is basically the central nervous system for the entire operation. It's the intricate web that makes sure every single person and every single part is connected and communicating with each other, instantly and effectively.
And this whole nervous system really works on three core flows. First, you've got the flow of goods. That's the physical journey of the parts moving from a supplier's warehouse to the hangar. Then you've got the cash flow, which moves in the exact opposite direction, from the airline paying back to the supplier. And finally, weaving it all together, you have the information flow. This is a constant two-way street of orders, shipping updates, and technical data that keeps the entire system in perfect sync.
All right, so we've got the maintenance crews, and we've got the supply chain that feeds them the parts they need. So how do MROs strategically bring these two worlds together to keep those planes in the air?
Just try to wrap your head around the complexity here. A modern jet has millions of individual components. You can't just keep a spare for every single thing. A single spare engine can cost tens of millions of dollars. So how in the world do they manage an inventory that massive?
Well, they do it with this incredibly smart hybrid strategy, one that perfectly balances being ready for anything with not breaking the bank. It's called the push and pull strategy. And here's where it gets really clever. The strategy has two sides. On one hand, you've got the push system. This is for all the common, low-cost, high-turnover parts. We're talking screws, bolts, O-rings, seals. MROs forecast how many they'll need and push them into their warehouses ahead of time so they're always right there when you need them. Then, on the other hand, you have the pull system. This is reserved for the big-ticket items. Engines, landing gear, those complex avionics systems. These things are way too expensive to just have sitting on a shelf, so they are pulled from the supplier only when a specific need or an order is actually made.
So what this hybrid approach does is give MROs the absolute best of both worlds. They get the speed and readiness of having all those everyday parts already on hand, but they also get the huge cost savings of not having to store multi-million-dollar components until they're truly needed. It's a perfectly tuned logistical balancing act.
And really, this is the main takeaway. A modern airplane is an incredible feat of engineering. No one's arguing with that. But the system that keeps that plane flying safely day after day is an equally impressive, if not more impressive, feat of global logistics.
Which kind of leaves us with one final thought. The maintenance schedule for an aircraft is planned down to the minute. It is incredibly tight. But the global supply chains that feed it are full of unpredictable things: delays, customs headaches, geopolitical issues. So the ultimate, ongoing challenge for this entire industry is this: how do you manage a world that demands perfect schedules against a reality of constant, unpredictable change?